I don't think there's even been much progress since the 80s, if we're honest with ourselves. And that seemed odd because we contrast this with software development. And now with AI coding, it's fully democratized. The end game is done. But we've made so much progress over the last 3-4 decades here. And in hardware design, we've made no progress. That seemed weird. And it seemed like a missed opportunity. And then, right, you looked at the incumbent tools, you realize there's no automation, no collaboration in these tools. Machine learning is completely absent here. We can probably do better in this. And so we got to work.
Matthias, coffee, tea, or something else? What fuels your mornings?
Coffee for sure.
Yeah.
Double shot, espresso. It's my jam.
Okay. Get a jump start on the day.
That's right.
Yeah, I'm a double espresso man myself, actually.
Yeah. I went off coffee once.
Oh, yeah?
Sorry to interrupt. Yeah, for probably 2 years or so, And I thought it was so hard, right? I feel coffee is such a physical, they'll say addiction maybe, right? So yeah, the first 2-3 weeks I was like, withdrawals. But then, then it's fine. But yeah, I like my coffee. It's a good, treating yourself in a morning ritual.
Yeah. Why did you, I'm curious, because obviously there was a whole thing a couple of years ago, like get rid of caffeine and dependency and all this stuff. Like, why did you want to stop?
So this was about 12 years ago or so.
Okay.
And I don't know, I just got into like this phase where like, oh, what are all these things that I feel like I depend on, right, in my day-to-day life. And then coffee was one of them. I was like, ooh, that'd be so hard to give up. Let's see if I can give up, right? Let's see if I can do that actually.
Yeah.
And so, yeah, you can do that, I gave up alcohol, right? And that one's interesting too, socially, because you realize that a lot of social gatherings are architected around alcohol. Like meet friends in the bars. It's about drinking. Like barbecues are surprisingly a lot about drinking, actually, right? If you go there without the intention to drink, bars the same thing. It's kind of like, what are we doing here? We could be doing something more fun, right?
Yeah.
And so it then changed my whole social lifestyle and what I would do. I became more outdoorsy through that. Yeah. Right? Because if you do outdoor stuff, you want to get up early in the morning and not be hungover, right? And then, as we all get older, also, like, I think we now metabolize alcohol
differently.
less well. So, yeah,
Interesting. Oh, well, that's cool. And did you keep both of those? Well, obviously you're back on coffee now, but
I'm back on both of them.
Yeah.
But I have a different relationship with them now.
Yeah.
Right.
Interesting.
And so it was cool for that.
Love that.
So coffee I do in the morning. But for example, alcohol I do rarely, and that's maybe like a general trend now. I think with people, right? I think all of us are drinking less these days.
Yeah, the alcohol industry is definitely struggling from the newer generations, but then also, like you mentioned, as our generations are getting older, it's less and more mindful about where you spend your time, money, effort, energy. So yeah. When you were a kid, what did you think you'd grow up to be?
I had like a couple, similar ideas. One was I wanted to be a circus director.
A circus director?
Yeah, like running a circus, right?
I've never heard that one before. Okay.
I was really into circuses as a kid, and the whole idea to have this like traveling show, in a tent and all that. I love the combination of like art and logistics and all that. And then, all these things you forget about as you grow up. And then decades later, I found myself with some friends running a Burning Man camp. And then one day I had this realization, oh, Matthias, this is the circus.
Yeah.
Right? That you wanted to run as a kid. Here it is, right?
You did it.
You have this like, temporary wandering thing, the mix of art and logistics and technology. It's all here.
Wow.
So, check.
That's so interesting. Okay, cool. What's one technology that you can't live without?
I guess you could jump to say something like phones or AI. That feels mundane. But, look, I have a cool example. I got an AI robot vacuum. And that thing's amazing. I don't know how I dealt with these Roombas for so many years, who are like so loud and clunky and dumb. Yeah.
What's the AI robot vacuum? Which one's that?
It's a Matic.
Okay. Yes, I do know them. Interesting. Okay, cool.
Very
I'll have
quiet,
to look at those.
It's very smart. Doesn't close doors behind it. Doesn't get stuck on Legos or Nerf darts.
Anything.
Anything for that matter.
Anything. That's cool. Okay. All right. Last one. If you could fast forward 10 years and see one impact that your work has made on the world, what would you want that to be?
You know that people stop saying that hardware is hard, right? It's been such a self-learned helplessness kind of thing that we all adopted over the decades. Oh, don't do hardware. Hardware is hard.
Yeah.
Don't do that. Let the big companies do that. They know how to do that. They can do hard things. No, that's not true. We all can do hard things, right? And we all can be part of making hard things less hard.
Awesome.
So that's, I think, the impact we want to have in the world.
And I think that's going to resonate a lot with our listeners. Welcome to Machine Minds, everyone. I'm your host, Greg Terrusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Matthias Wagner, founder and CEO of Flux. Thanks for being on the show today, Matthias.
Thanks for having me on the show, Greg. Excited for today.
Yeah, my pleasure. Let's jump into it. So you've been building at this intersection of hardware and software for a while now. What originally pulled you into that world?
Yeah, great question. So we started a company in 2019, and before that, I worked at Facebook for many years. And, at Facebook, I think two things became clear. A, that machine learning was here to stay and was incredibly powerful, right? And there was only going to be more of it. We didn't call it AI at the time, but, same thing now, I guess. And then the other thing I realized was that the opportunity space in just pure software was shrinking exponentially, right? Because as I looked around, I was switching teams there, and I was looking around what else to do, and it was kind of a lot of stuff where we already were the category winner, or there was already a category winner, and there was very little space in between left, right? You could make incremental improvements, but not step change improvements anymore. And that's kind of what drove me back into a little bit of hardware. I ended up quitting, took the whole summer off working on Burning Man, animatronics, hardware projects, right? And then later that summer, I had the realization that, I was living in Oakland. I'd built a workshop in my backyard, and I had this realization that as an individual now, I have access to the whole global supply chain, right? For $40, I could get something custom made in China and sent back to me within 10 days. And that's just a capability that a decade earlier just didn't exist. That would have been crazy to even think of that, right? And then here I am now. But what hadn't changed is that designing whatever you want to manufacture was just as hard as it was in the 90s when I first started using CAD tools, right? And frankly, I don't think even there's been much progress since the 80s, right? If we're honest with ourselves. And that seemed odd, right? Because if you contrast this with software development, now with AI coding, it's fully democratized. This is the end game is done, right? But we've made so much progress over the last 3-4 decades here. And in hardware design, we've made no progress. And that was, that seemed weird. And it seemed like a missed opportunity. And then, right, you looked at the incumbent tools, you realized, man, there's no automation, no collaboration in these tools. Machine learning is completely absent here, right? We can probably do better in this.
Interesting.
Right? And so we got to work.
Were there key experiences or roles or situations that really opened your eyes to that or shaped how you think about engineering tools today? Or was it just a culmination of all of this realization along the years that there hasn't really been any innovation in that area?
Good question. I think, a good example I have is that when I first started writing code in the late 80s, early 90s, the way we would do version control was all manual. We would exchange floppy disks. And if my buddy had edited the same file that I'd edited, we would have to manually merge this now.
Yeah.
And that's crazy.
Yeah.
Right?
Yeah. When you try and explain it to people now.
Yeah. Right. It's what? Right. But that's how that got made. Right. And now, of course, things like Git and version control came into play decades ago already. But now with AI, even the conflict resolution is done automatically. I don't even remember when I last resolved a merge conflict manually in a PR, right? A year ago or so, right? And so Yeah, but so again, so it was these kind of things, and then again, you looked at hardware design, and you're like, this is the same stuff. There's no fundamental improvements, right?
Yeah.
Yeah. It was like, I kept complaining about this all summer that year to friends. And eventually friends said, look, Matthias, every time I hang out with you, you complain about this. You either need to do something or shut up, right? And so then here we are.
There you go. There you go. Well, all right, let's switch gears and just go very much into Flux. And for people that aren't in the hardware world or aren't as familiar, what is Flux and what problem are you solving?
Yeah. Flux is the first AI hardware engineer. Right? If you think about in coding, you have like Cloud Code and Devin and Codex and whatnot. And we're essentially building that, but to make electronics, right? To make something like an iPhone, you know? We're starting here with the guts of it, which is, the actual motherboards inside these devices, the PCB boards. And as we're making progress here, we're expanding to the firmware, the enclosure, dealing with the logistics of manufacturing things for you. And it's all driven by AI agents.
Interesting. So, well, traditional PCB and electronics design tools haven't changed much, like you mentioned, but what's fundamentally wrong with them? Like the most recent versions or what people are using outside of Flux? Is it still very manual? Is it super clunky? Are they not integrating with stuff?
Yeah, good question. I mean, look, it is so manual and clunky that most people don't do it. Think about how many people that make software versus people that make PCB boards.
True.
Right?
Yeah, we help clients on the electrical engineering side and PCB side, and it's so true. When you look at the volume of people that are actually working on it, it's crazy.
And then also look, like a lot of software engineers, like a meaningful percentage, has an electrical engineering background.
Mm-hmm.
What do you think that is?
Yeah.
Right?
Interesting.
Because it's so bad, people don't even want to work in that field.
Yeah. So with something that you're building, it sounds like either you're going to attract more people back to the space or enable people who aren't traditionally trained in that to be able to do it or be open to doing it.
Yeah, exactly. I mean, if you look at our customer base, about a quarter has ever designed a PCB board before. The other 3/4, they are technical users, so they are software engineers, industrial designers, mechanical engineers, and so on. Or they are electrical engineers, but they just haven't designed a PCB board before. Not because they didn't have the need for it or didn't want to, it's just like too cumbersome, right? And so then everybody goes down the way of least resistance. And so then in this case here, right, people just bought some OEMs, right? We have this great customer, they build vending machines for snacks and beverages. And they would essentially previously, right, they needed a board from an OEM for the credit card reader, another board for like the bills and coin reader, another one for the display and the keyboard on the vending machine, another board to control the motor, the servo, right? And if they wanted to like inventory it over internet, over IoT, they need another board for that. So you end up with like 5-6 boards in a single machine. They all come from different vendors, from an OEM somewhere, go for 4 distributors before they end up with you. Lots of compromises on like the choices and features you can have here and how they all interconnect. By then the cost of like integrating them into a single vending machine on an assembly line, the cost of like keeping that vending machine running out in the field, right? Because you need to bring replacement parts for all of this when it breaks down. And so now you contrast that with them just using Flux, where they can make a single board for the whole machine, right? It's got exactly the features they want, right? And right, so they're on manufacturing now, they pay pennies on the dollar because they pay virtually, material costs to a vendor in China to get this made for them. On the assembly line is one board to put into the machine, and if the machine breaks down, it's one board to replace. And then plus now that they get all the features that before they couldn't have. So the competitive advantage now is not just a cost reduction and like reduction of friction, is that you can now also like have features in the machines that others can't have.
Wow. Yeah, that's a game changer for anyone that's building in that space who understands. I mean, that's huge. You're building in the browser. Why is that such a big shift versus legacy desktop tools?
Yeah, good question. I mean, first, right, I don't think many people had the courage before to build tools like this in the browser. right? I think people who are like hardcore about cat kernels and stuff look down on JavaScript and browsers. But I think that created an opportunity to show that you can do that, and then what the advantages are. And what are the advantages? Well, you have frictionless collaboration, right? Adoption is frictionless. There's nothing to install here, nothing to configure, nothing to set up, you know? I mean, have you ever tried to like make a Cadence Allegro instance work on your Windows machine? You know, that's like weeks of back and forth with support. Here, you know, you sign up as if you sign up for a LinkedIn account, right? And then of course, right, the ability for us to ship improvements hundreds of times a day, right, because it's the website, and we have this continuous loop here, right, allows us to also learn much faster and fix issues much faster and improve things much faster than if you're shipping a native Windows application once every 2 years.
Interesting. Yeah, that's also a game changer, because things are changing so quickly these days. Like products improvements, it's just crazy. And if you're not able to update in real time, that's going to be a problem.
Yeah, especially in this AI space now, right? Where we're like day zero here of AI still, and things are moving incredibly fast, right? I mean, kind of like every 3 to 4 months, you've overhauled your whole stack, you know, because that's how fast the advancements are. And so, imagine shipping a native app here, right? You'd be decades behind. You know?
Yeah. You mentioned collaboration there. How does that actually work inside Flux compared to something like traditional EDA tools?
Yeah, good question. I mean, so in traditional EDA tools, right? First of all, the files are typically binary files. So yeah, you could stuff them into a Git repository, but you can't diff them, right?
Okay.
You can't search through them in that sense, like you can with code, for example. And so then you can also like not merge. You can't do conflict resolution, right? And so what we've built in contrast is more in the intersection of how like something like Google Docs, Figma, and GitHub works, where you know you can collaborate in real time together and come together and make changes, and you can see what others are doing in your project, right? Just like you can in a Google Doc or in a Figma file. And then we're matching that with this like idea of this like hub that GitHub is, where, you know, in software, if you want to make something, you're typically relying on modules that other people have built, whether it's an encryption module or like a module to deal with currencies or, you know, whatever it may. And then in hardware, these modules are essentially the semiconductors. And to use them, you need like a digital representation of them. And that's a collaborative community effort on Flux, which has been amazing, right? Users have created like millions of parts that way. And they're maintained that way, right? And they have like they're very rich on metadata because again, the AI agent uses that metadata, right? Access to the data sheet, the application notes and stuff like that, right? Also like having real-time integration into the marketplace. Be like, look, is this component available? How many units are available? What's the lead time? What's the price going to be, right? Because that's the other fundamental thing is like that. What's different about designing hardware than writing software is that to manufacture the hardware, the components you use need to be available. Right? If you're building a board here with 500 components and one of them has a lead time of 200 days, well, guess what just happened? The lead time for your whole board is 200 days, right? That's a problem. Yeah. And so that's also something that, like, you know, the traditional tools haven't done at all. Right? You design something, then you find out that half the components aren't available, then you redesign, then you find out that the next a subset of components aren't available and rinse repeat, right? And we're like here, we're front loading all that. So I think also if we're thinking collaboration, we're not just thinking collaboration between you and your team, but also you and your vendors, your suppliers, your manufacturers, right? I always tell people like, look, making hardware is the ultimate team sport. Right?
I like
it's the ultimate distributed discipline, right?
Yeah. It's interesting because there's a number of companies right now in the space. Obviously, I operate a lot in robotics, and that are just doing the software side, right? Building a brain or building that, but then realize that there is a hardware component that they need, and they're so used to dealing with software that the hardware manufacturing part or build ends up being a huge bottleneck for reasons like this, you know, because they're so used to just thinking software side or working at a company that already has a robust hardware function.
Totally. And software that gets inherently developed agile these days.
Yeah.
and hardware still gets developed in a waterfall approach. And that's like two worlds colliding. It's because I think oftentimes software people think, oh yeah, these hardware guys, they do it like us too now. No, they can't. They don't have the tooling to work like software engineers. Right? And again, and that's what we're helping with, what we're fixing.
This is that modernizing hardware design that you've spoken of. Yeah.
Yeah, modernizing it and automating it.
Yeah, I like that. So you mentioned before, like GitHub and stuff, like software's obviously had GitHub, Figma, other cloud native workflows, but hardware hasn't. Why has it, in your opinion, lagged so far behind? Why hasn't this been addressed before?
I mean, I think one thing that's nobody's fault per se is that, to make hardware, you need to have access to manufacturing capabilities and you need to have access to materials. And that was until like very recently, a luxury of large companies. You had to be Northrop Grumman or Apple, right, to have these kind of resources. Like I used to run like a mid-sized hardware software business in Germany in the 2000s. And, for us to make something in China custom, we had to fly there. And we had to like network our way to like a factory owner that we could trust.
Yeah.
Right. And for many device categories, you just don't have to do that anymore. You can do this online, you just never go there. Right. And I think that's only going to like increase, right, the like amount of things you can make without ever going there, right, by just sending the design files over. And so I think that's a big thing, right? I think in software, right, I mean, with the rise of PCs in the 80s, late 70s, 80s, right, everybody suddenly had a machine like this at home or at the office or at school, right? And you could just write software, compile it, and run it there, right? So that was cheap, low risk, very accessible. And half of it didn't happen because, people didn't have access to the manufacturing supply chain. And now we do, right? And so that's why this is rapidly changing and changing fast.
Do you see Flux becoming like the Figma for hardware, or is that too simplistic?
I think that's an in-between step, right? I think that if you can prompt something like an iPhone into existence at a fraction of the cost of what Apple charges you, right, then this isn't just a market of like tens of millions of customers or hundreds of millions, but then it's $1 billion user business, right? And so, right, yeah, look, we're here to take the heart out of hardware and to democratize that, right? And what it's going to lead is going to, I think, be really interesting, right? I think we see that we get a little bit of taste of that in software now, where like people are now building an iPhone app just for themselves. But because the cost of execution is like virtually zero now. And imagine what's going to happen with hardware if the cost of execution becomes virtually zero.
So this is
what you realize is that the world is a big place, I guess, right? If you think about, if in the 70s I would have told you we needed, a second take on task management software, you would have told me, man, what's wrong about this task management software we have here? This is just managing tasks. But it turns out that if you democratize making software, what you find is like that there's a lot of different types of businesses out there in the world and people, and they just have different needs for the task management software. Right?
Do you think
it's probably
do you think this unlocks a new generation of builders, or just makes like existing engineers and teams faster and more creative?
I think both, right? But much more so the former, right? I think it's always the new entrants who leverage these capabilities faster, right? Because they have left, you have this innovator's dilemma. If you've already built a whole organization around making hardware the old way, very difficult for you to like change everything, right? Because you have this like organizational inertia, from the size you have and the expectations in terms of revenue and all that kind of stuff, right? And so I think that's difficult. I think what we're going to see, but look, some organizations are going to be able to do that, right? And then, but I think for the most part, it's like, it's what you said, it's like there's like a whole new vertical being created now of people that previously couldn't participate here in making custom hardware, and they now can, right? And I think that's exciting, right? I think we have another great customer is like company in South Africa. It's a bunch of farmers, actually. They started building with Flux their own farm automation equipment.
No way.
And
Where
you'd be
in
like,
South
well,
Africa?
and this feels like a solved problem, right?
Yeah.
But it turns out, no, they have specific needs. It's cumbersome to buy from existing companies in North America or Europe the stuff. And it's just easy now to make it themselves. And so they do.
Interesting. Where in South Africa is that? Do you know?
It's somewhere on the countryside, so probably like north of Cape Town somewhere.
I'm half South African, that's why I'm curious. So
I've never been there, right?
Yeah,
I only hear from them on our community Slack.
Yeah. That's interesting.
I've seen photos of the farms, but I wouldn't be able to tell you where exactly they are.
Yes, a lot of farms out there, a lot of sugarcane fields. And you don't think about stuff like that. Like if all the innovations happening in places like North America, but then the cost to get those products, because obviously the rand is so poor compared to the dollar. So you can't be importing machines. So yeah, that's interesting.
Yeah, exactly. And the world's a big place. I think that's also easy to underestimate when you live here in these metropolitan areas in North America or Europe, right? That the world is a really large place, and you underestimate the specific needs people have and the constraints they're dealing with, right?
So true. So true. Where does AI actually fit into electronics and PCB design today?
Yeah, good question. I mean, where we're at, if you think about the process, you typically, right, you define some product specs, some requirements. You can leverage AI for that, for starters, right, including your market research and all that. I think from there, typically people go to more high-level architecture. What are the central components here, right? If we're building a credit card reader, well, we need the credit card reader itself. What kind of other UIs here? Maybe a little display where it can show you, hey, this worked, this didn't work, right? We need an internet connection, so we need a Wi-Fi capability or 5G or something here. Then we need an MCU, right? So you rely on the high-level components you need with the model. Then the model, the Flux in this case, the agent will go out, source these components in the marketplace, figure out the vendors, the distributors, where to get these things from, then help connect it all, find all the support. You need a power supply, right? So it's going to put that together for you, right? What's going to power this? Is it going to be from battery, USB-C, you name it, right? And plug it all together into the schematic, and then review that all with you together. And then from there, take it into the actual, mechanical layout here, right? So actually placing these components, and then connecting them physically, and then go for another review step with you. I mean, in some cases, right, if you think this is a voltage booster, right? You have these big capacitors here, you need to size them, right? And sure, you can do back of the napkin math, right? And that's in some cases good enough. But for example, our agent has access to a simulator, right? So you can actually simulate the circuit and really precisely size these capacitors.
Yeah.
Right?
Okay.
And so that's all kind of stuff that most engineers, it's above their head to operate a simulator. It's much easier to just build the thing and watch it blow up and try again, right? And so, here we're coming with a lot of automated tooling at this, where we can reduce risks upfront, right? Where you have to go through less physical iterations of the product before you get there. And then just like in software, right? Having to worry less about the execution creates more space to iterate on the actual product, on the idea, on the business around this.
Yeah. What parts of that workflow do you think should never be automated?
Ooh. I'm not sure there should be anything that shouldn't be automated here.
Really?
Yeah, I would even go as far and say, look, I think AI models, AI agents should even research opportunities within your business to build new product lines or improve existing product lines.
Interesting.
And again, I contrast that with software where that's already the case. I mean, I see that with us every day, right? We use AI to identify opportunities, within our product to make improvements, and then AI implements it, reviews it, right? In some cases, we still use the QA by humans, and then we just ship it, And so you can go from an insight to having a solution in production in 30 minutes. And that's, that's mind-boggling, right?
Crazy.
Because even in a fast-moving field as software, this would have taken weeks to months before.
Yeah. I was going to say, QA or testing or quality in general probably still needs human in the loop, but I guess there's a lot of it that AI can still, when it's a physical product, at least.
Yeah.
How do you think about that?
It depends what it is, right? I think some things, AI models, even the current generation, are perfectly capable of QAing for you, right? And then there's other things that need a human, that need human judgment or human taste, right? To decide whether it's good. Yeah.
How do you balance speed versus correctness in hardware where mistakes, obviously, they're super expensive in the real world?
Pragmatism.
Yeah.
No, but like what I mean is like, right, that like I think you identify areas of the business and product where you have to be conservative and move slow, right? And then the other areas where you can be fast and scrappy, and then a lot of gray in between, right? And I think, right, as we're here getting better at delivering the product we're building, right, that's part of the getting better, to better understand organizationally, hey, this is a high risk thing we're changing. Here's the process we need. But it's like, no, this, just ship it.
Interesting.
Right?
Okay.
Or like, just ship it, but like, the level of scrutiny needs, right? Look, this is an infra change. There's unit tests. It's pretty straightforward. That can just go out, right? Where it's like, oh no, this is a change where unit tests won't cover the whole spectrum of possibilities, where even automated like end-to-end tests won't, right? You need a human actually with their mouse clicking around here, and it has to feel right and behave right? And so then, yeah, here you need a human. In some cases, you need multiple humans, right, to find all the edge cases. So,
Okay.
I think, you're operating here on a spectrum with these things.
Makes sense. I want to shift gears and talk more about building the company, because we have a lot of founders, first-time founders, aspiring founders that listen to the show and get a lot of advice. So I'm always curious to hear what people's journeys have been like and how they go about stuff. So with Flux, what's been harder than expected about building the company?
Quintessential is the word. The quintessential moment early on. A friend of mine is friends with Dylan Fields from Figma. And so like 6 months into the company, Dylan hopped on a call with us, and we were just going to, demo him the very early, very crude product we had at the time. And like 2-3 minutes into the demo, he said, guys, look, I get it. I believe you can build this, what you're talking about, right? And I believe it's valuable. The hard part here isn't going to be to build this. The hard part is how you're going to get this funded. He said, because what you guys don't realize is that from where you are now to have the first paying customers, it took Figma 5 more years. How are you going to fund 5 years of no revenue, right? In a space where even before AI, investors essentially expected revenue within like 12 months, right? And so we went 5 years without revenue. And so I think that was the hard part.
Wow. So that happened to you as well, the same 5 years?
Yeah, actually, on the dot.
Wow.
That's exactly how much time it took.
That's crazy that he called that from the start.
Yeah, because he had gone through this with Figma.
Yeah.
Right? He knew what it would take to build a design tool in the browser, of like similar complexity, and get an actual first paying customer. So yeah, no, he was on the dot right.
So, okay, can we go into that a little bit more? Because obviously finding the right investors and partners early on in a company is crucial. Unless you're self-funding somehow, you had a great successful exit, and obviously this is a small percentage of people that can do that. They have their own funds, family office, whatever. How did you go about that? Finding investors with like long-term horizons or able to have the bankroll that you needed?
Yeah, good question. Maybe in general, right, it's easier to raise money that early from operators, from people who've been founders, product managers, engineering leaders, whatever before. right? Because they can understand on a product level why this is going to work and why this makes sense. It's very difficult to get, institutional investors where their background is more like a finance background to understand these things. But, you can use these operational investors as leverage.
Yeah.
Right. Once you get especially once you get into like VIPs here, like people who have been the CEO and founder of a multi-billion-dollar company, right? Then that opens a lot of doors. That's when that institutional investors will start paying attention, right?
Yeah, that makes sense. I think it's kind of the same as when you build a team. People are always looking for logos and people that have been high flying somewhere else because it looks good on a deck sometimes to raise capital.
Yeah, totally. And I think like operators, right, they can use their own judgment and experience to judge these opportunities. But if you don't have that background, you need to rely on something else, right? Some different signal.
For sure. Hardware adjacent startups, they have like long feedback cycles. How do you manage that as a company, or at least in the earlier days?
Yeah, I think that was just part of this like long journey, right? Because the feature density required in this space was so high, we were never going to be able to compete there at the beginning. We were never going to be able to come head to head for existing seats anywhere. And so we had to go bottom up into the market. And so how you do that for the most part is with new companies in the space. And then you grow with them. And you take bets. Some of them work and some of them don't work out, right? And that's how you create a new category. It's probably the only way to create a new category, right? But you have to have the stamina and the belief and the resources, to see it through. And look, I'm not going to lie to you. Like, we went out of business 3 times, like almost 3 times along the way, like hours away, right? And then, but we kept believing, right? We kept pushing the team and investors. Be like, no, this is going to work. Just, let's keep at it.
That's
right?
awesome.
And what's cool about that is, right, is it builds the culture at the company.
I was going to say, yeah.
Because it's an incredible, look, it was painful, but it was an incredible filter to have the right people on the team who also believe, right, either in the vision or you or the rest of the team or all of that, right, and who see it through. And now we have this collective experience together of having been, close to the brink for a long time, and then suddenly it starts working, right? Because for 5-6 years, but whatever graph you looked at, it was pretty much flat. Revenue certainly was, user adoption certainly was, and then eventually, it started compounding and working, right? And we've seen that all together now, right? We've seen that if you can do hard things, right? Yeah. And persistence is the number one thing about it. You just got to keep at it and not give up.
That is great advice. It's great. Right. Yeah, it's great also to hear that, because people that you always think about, you just see the success, you see where someone is now or where a company is now, and you don't hear, which is why conversations like this, I think, are so important, to share the journey and share the close calls or the missteps or things like that, because people can have a false sense of hope or get jaded's not the right word, but like what's the word that I'm looking for? They just get bruised and they don't want to progress down the path that they've started on because they have like a misstep or almost go out of business, or someone doesn't believe in them, or their first deployment doesn't work.
And you start becoming short-sighted, right? You get bruised and you optimize for like more immediate rewards, right? Whether it's in your career or as a founder or whatever it is, right? I honestly think an advisor told me that a long time ago. He said, like, look, this is not unlike dating. You need to go on a lot of dates, most likely.
Yeah.
To learn about people and yourself, right? And to learn to do the dance, and then it will work out, right? I think interviewing for a job is the same thing.
Yeah.
You just have to keep putting yourself back together and go out and do the next thing, and you'll learn along the way. You learn about yourself, right? What do you really look for? What's really the right role, company size, team, how to represent yourself better, how to ask better questions from interviewers, right? And so, yeah, it's a persistence game.
Yeah, for sure.
But it's tough when you're in it, right? To be like, oh man, fuck this shit, right?
I know, yeah, for real.
Like I hate interviewing, right? And whenever a friend is like, oh, I'm interviewing, it's like, oh my God, but look, just keep at it, right?
Yeah. Well, talking about interviewing, what kind of people thrive on your team today? Like, what do you guys look for?
Great question. I think, we leverage AI internally to the max. And I think our observation has been that, yes, you need to be a domain expert in whatever the role is you're having. If you're an electrical engineer, well, you need to be a really great electrical engineer or software engineer or marketer or whatever it is, right? But I think on top of that now, you need to be a really crisp communicator, especially written communication, because that makes you way more effective at leveraging AI. Right? And I give you a simple example. Like we just hired somebody a couple of weeks ago, electrical engineer, and she just, right, intuitively writes really crisp Slack posts, Slack messages. It's like non-verbose, to the point, and almost always can you just tag an AI agent to execute the work, right? And that's and then in 30, 40 minutes, you have whatever the change is landed in production that way, right? Extremely efficient. And then there's other people, right? They're like too vague, they're too verbose, they don't provide all the information required. And then it takes a lot of teasing to extract the information from them, right? And then that makes the whole process inefficient.
Yeah, that's interesting. How do you think about hiring when you're building something that sits between software and hardware?
Yeah, that's changed a bunch, right? Again, AI has changed this. Because before, right, you needed a domain expert, somebody who knows about hardware engineering, electrical engineering, and then you needed a software engineer to execute that. You need at least these two people. You probably needed a third person with product taste, right? And look, sure, in some cases you can find all three in one person. Typically, you needed at least two people, most often three. However, right, with AI coding now, if you have a domain expert, like an electrical engineer, who is articulate and maybe even has a little bit of taste, then they're like an army of one now. That whole loop, they can operate that themselves. And they can run many of these loops a day, right? They're like an unstoppable force, right? And so that's right now what we're trying to hire for. And then, of course, look, not all problem categories can be solved with AI coding. You still need real software engineers, right? But you just don't need as many of them anymore as before. That's just an example. Same with product managers, right? You don't need as many of them as before. And the product managers we have, also the product designers, right? Yeah, they're shipping a lot of the stuff themselves with an AI coding agent.
Interesting. You're definitely able to do a lot more with less these days, especially if you've got a team that is very much using and incorporating these tools and is able to see things through those different lenses, right? Software and product, or hardware and product, and full system.
I also since you asked earlier about the reviewing QA part here, right? So for example, look, if a domain expert asks an AI coder to make a change in the user interface, it's fairly easy for them typically to review that and QA that, right? But imagine having to make a change to the payments infrastructure. We're just recreating the scenario a given user could be in to be eligible for a certain upgrade and going through the flow, right? It's just like a clusterfuck of a process, right? And then that's where humans still strive, to recreate the scenario, to be able to QA the actual change you just shipped, right? Yeah.
Where do you think the biggest bottlenecks are in robotics and hardware innovation today?
I think let's start with the good, right? I think the good is there's a lot of momentum now, right? Because the AI models are very capable now. I still think we're not trying enough things here. Mm-hmm. Right? We're still so constrained by this waterfall model of making hardware from the past, right? That we're not able to try enough things and take more swings and enable more people to take more swings. right?
If you
I
could,
think if we want that Star Wars like a future where robots are ubiquitous, right? They're everywhere,
yeah,
right? And they're just part of the whole. You're gonna need not hundreds or thousands of companies building robots. You need millions of individuals be able to build these robots. Right? Just like there's millions of individuals today able to be to build software.
Yeah, building apps that they can just put out there easily.
Yeah. Because again, also, I think the world's a big place.
Yeah.
And short of these humanoid robots that can do everything a human can do, right, and that are cheap, which is, a tall order, you're going to need a lot of like domain-specific robots.
Right.
Right? And what even is a robot? I mean, you could argue that a vending machine is a robot. It's a crude robot, but it's a robot, right? It replaces like a human that before served you, and sold you, a water bottle from a cooler.
Yeah. 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 We've had this conversation on the show, a dishwasher, same thing, microwave, all of that. Yeah.
Yeah, like a dryer, right? All of these things. Sure.
Yeah. Yeah. Just because it's now categorized as an appliance, you forget that it's actually automating something. Yeah.
Yeah, even your intercom in an apartment building, right? To be able to have a camera downstairs and a microphone and a speaker. I mean, you had to go there. It's your doorman.
Yeah.
Yeah, it's a doorman, exactly.
Yeah.
Yeah.
Interesting.
Or, elevator operators. Remember those?
Yeah.
Yeah. Right. So I think these are all robots, but of course, the keep pushing the boundary here, the bar keeps getting pushed.
Do you think as an industry that we're underestimating how important tooling is to the pace of innovation?
Absolutely. I think software engineers got that right a long time ago. And I think the reason they got that right is because software engineers are, I think, one of two professions in the world that can build their own tools. Right? The other one are here, what's the English word here? Like a metal here, like a welder, like a, what are they called? Anyways, they can weld their own, if you know how to weld, you can weld your own tools to help you with welding. You can weld jigs and all that kind of stuff, right? So, those are the only two professions who can make their own tools. And so I think that's how they got a head start to make their own tools. Like a lawyer can't make their own tools. Like a woodworker can't make their own drill, right?
Yeah, true.
Yeah. And so I think in hardware too, right before, they weren't able to make their own tools.
Very true.
All this is changing now, right?
It's crazy. It is crazy. And how fast it's changing as well, and how capable and competent these models are and these tools are. It's wild.
Yeah. And also like, look at the big Silicon Valley software companies like Google, Facebook, how much they have invested in infrastructure. Like PyTorch, which is the tooling used to train transformer models, to train large language models. That's an open source tool that was developed at Facebook. Like React too, right? That came out of Facebook, right? Which is like now the standard way to build web apps. TypeScript, that came out of Microsoft, open source, right? So these software companies have like, not just software engineers have created this culture of like building better tooling. Then like the companies, the big ones that came out in the last 20, 30 years have also then further invested here and made the stuff publicly available.
Yeah.
Right. And I think we need to see that also happen in hardware more. Like hardware companies have historically been very like to themselves.
Yeah.
Right?
Yeah, they have.
And I think that will have to change if we want to make robots ubiquitous.
Yeah, you're seeing a much bigger push now for open source in especially the design space and things like that. And hopefully it just carries on across tooling and all of that stuff, because the hardware tends to be the biggest bottleneck, right? Unless it's going to be fully commoditized and capable.
Totally.
Yeah,
Totally.
that's...
And look, and it's not all bad, right? Like if you look at a PCB board, that is a standardized form factor to integrate semiconductors, into a system, right? So it's not all bad, but it's just like I think there's a lot more work to be done here.
Yeah, that makes sense. I'm curious, before we end the show, just a bit more on like you and your personal operating system, if you like. How do you structure your time as a founder right now?
Right now, I'm a terrible example. because I work too much. We have this, using AI agents to do work is so addicting.
Yeah.
Because it's always just like one more prompt, just one more prompt. Then I go to bed. Then I go home. Just one more prompt. Then I go to lunch, right? Let me just see what comes back after this prompt, right? I'm so close. And so I think what I experience myself, but also in our team, is that we're going for like a very kind of like a addiction phase right now. But it's like so accelerating to be able to execute so much as a single person.
Yeah.
Right. And so fast. And so, right now I get up at 7:30 and I work till 2, 3 a.m., 5-6 days a week. And then, Saturday or Sunday, I used to catch up on sleep, but then I sleep 12 hours in one go and then I'm back at it. Is that sustainable? No, but it's just so much fun right now. Right. And it's kind of like, I think a lot of things in life are like surfing, right? There's a lot of waiting on your surfboard out there watching the horizon. And then when a wave comes, you need to paddle.
Yeah.
And you need to go ride it as far as it goes, because God knows when the next wave's going to come.
Love that.
Right?
Yeah, it's a great analogy.
But here right now, the waves here.
Yeah.
And there's more waves coming, and they're big. So let's just, let's just ride them.
I don't know if this is something that you can give me an answer to apart from a double espresso in the morning, but is there anything that you do to stay sharp mentally and physically if you're working till 2 a.m. and up at 7?
It's not perfect, but what do? Right? A lot of water. I do take my vitamins. It took me a long time in life, but I take my vitamins every morning. That's important. Here is a controversial one, maybe not so controversial, but how bodybuilders have been telling us for decades how great creatine is.
Mm-hmm.
I take creatine every day for the last 2 years, maybe or so, and it's great for memory.
Yeah.
It's amazing. So I do that. And then other than that, look, I love winter sports. I'm a snowboarder. I have my son here every other weekend doing and then, in the winter we go snowboarding. And that's also time to recharge, right? I work for like 10, 12 days in a row, and then I have him for 3 days and we go to Tahoe and we just, we shred all weekend. And then that's kind of like the for me, the way to reset, right? And just stop overthinking all this work stuff.
Love that. That also is, forces is the wrong word. It makes you be intentional and present, and you also have, in a way, like that balance. I can work all out for this period of time, and I know intentionally I'm turning off for this period of time for that reason, right?
And the change of physical space I find really helpful, right? Because when I'm in the city here so long, I don't even realize that. And then I leave and I'm like, this is so nice to just be somewhere different. And then you're up in the mountain and the air and the views, right? And being out in nature all day. And then it's like, I'm big into adrenaline sports, snowboarding, kite surfing, all that kind of stuff. And like, just like, you have to be so in the moment.
Mm-hmm. Yeah.
You can't be thinking about 5 other things. It's a forcing function, and that works really well for me, right? It forces me to just let go of all that and be here now, be present.
Yeah, you have to be present. The same with like rock climbing and things like that. I've heard that from a lot of people, and it's a form of meditation and focus that you don't get in other ways because obviously your life depends on it in a lot of ways. So you have to be,
And people have different outlets. I mean, some people love to go running or swimming, and that is what gives that to them, right? So I think that'd be my advice. Find what it is for you. And look, maybe it's just like pumping iron at the gym.
Yeah.
Then go do that, right? But find the thing that helps you, free your mind and, be in your body.
Love that. Okay. Thank you. Before we wrap, looking ahead 5 to 10 years, what does the world look like if Flux succeeds?
Hardware is no longer hard.
Perfect.
People will stop saying that,
Yeah. I love that. All right. Look, well, Matthias, thank you so much for being on the show. I really appreciate it. I really enjoyed this conversation. So thank you.
Likewise. Great to have you. Good to be on the show.
Appreciate it. How can our listeners learn more about you and Flux and follow along for everything you guys are doing?
Great question. I mean, come to flux.ai. There are a lot of resources here about what we're doing, and you can try the product. I'm also on Twitter and LinkedIn, so you can follow me there, engage with me there. We have a community Slack too with lots of active users you can come and join. And then out here, I'm here, I'm here in downtown San Francisco, so I'm running around here, every day. Just check me out if you see me.
Perfect. Well, we'll put the links in the show notes, and obviously your LinkedIn and everything like that. And I look forward to staying in touch with you and hopefully seeing you in San Francisco soon.
Likewise. Talk soon.
Take care.
Thanks for having me on the show.